Hello, everybody. I welcome you for my project exhibition for educational technology, year 2, semester 1, 2022-2023. I welcome you as we discuss properties of matter and mechanics, that is mechanics and properties of matter, a senior 3 topic. With these 4 subtopics I chose today, I chose to discuss something on motion, display something on friction, on momentum with impulse, and then on work, power, and energy. So these are my 4 subtopics, and these subtopics will cater for my 42 learners that I left home, and these 42 learners are my previously taught physically. The one I taught them physically in Noya SS, I used to teach there, and I had 42 students, 23 boys and 19 girls. These 23 boys and 19 girls are more of aesthetics learners, and they like visuals like nothing. They learn best while they visualize things. So I need to give them more of visual aids than verbal wordings. So my learners do learn best and they perform well when they are presented more of visual aids. So I today present to you my class that are generally at class level of senior 3. Of course, they are also uniformly, they're relatively at uniform age range and interest with behavior. And my learners, I have 3 students who always take lead. Yeah, I have 3 students who always take lead in the class, but I can see one who is not actually performing well this time. I think there is some issue because last time he was performing well. I do recognize that after this, I have to take keen concept after him, and I get to know what Gerard is experiencing nowadays. I like that. So today our presentation will begin from a flowchart explaining what is under mechanics and properties of matter. With these 4 subtopics chosen, we have also their individual contents. And this flowchart tells us what we are going to cover down to the root of our discussion. And next, afterwards, I bring to you our first subtopic, that is motion. What is motion? A change in position of objects. How do they change? So we shall be discussing, and I'm using my mango folding here to explain more of how they fall. And this is now motion from rest to a point of motion, and then they also land on the ground. So that is motion. And this motion also in the next flow chart over here, we have the components of motion. So the flow chart or the word web here is giving us the components of motion. In the same subtopic of motion, we shall also be talking of how motion is described. So we have 2 types of motion, that is linear and non-linear motion. As you can see in our video here, boys are dropping basketball. They're playing the basketball and they're dropping the basketball. Also in our exhibition in the picture here, you can see the boy is throwing the ball up and the ball is again coming down. So again, kicking a ball horizontally and throwing the ball at a certain angle. Yet still, we can see the army in the picture, the ancient army, they are using projectile to attack their enemy. So that is a projectile in real life. So these videos and pictures are going to help us explain what projectile is. What projectile is. So projectile will be explained basing on what we can see. How do they aim at that basket pot? How do they aim at a certain goal point? How do you aim at a person at a distance? So you have to tilt or you have to throw at a certain angle. So that is already projection. So projection and projectile do concurrently move. And our next sub-heading Our next subheading under the subtopic of motion is talking of uniform motion and non-uniform motion. Under this, I drew a graph, and this graph will help us explain uniform velocity and non-uniform velocity, as well as uniform acceleration and non-uniform acceleration. So this would help us to explain how the particles behave, what is the nature of their journey. So I'm using a graph to explain. My acceleration uniformly and non-uniformly, as well as that of velocity. So the velocity time graph is going to help us explain that. In the next subtopic, we shall be talking of friction. What is friction? If you talk of what is friction, when we picture this visual, you can see that there is a position to motion as the motion is going in the other opposite direction, to the east over, if I may to say, or to the west, if I may indicate this direction of friction, as the pushing force is pushing inward. So this friction exists in all states of matter, starting from liquid, solid, gases. So friction in gases and solids are generally viscosity friction. And this viscosity friction has low resistivity. They has low amount of resistance they offer to the motion in liquid and gases. Yet still, there is also particles in motion. So particles in motion experience what we call kinetic friction. So the kinetic friction is the next level, is in the next level. So this chamber of levels gives us different amounts of friction. They give us the different amount, the strength of resistance they offer to motion. While there is a static friction, which is at the highest level. So this static friction here is showing you that the amount of resistance that static friction offers to motion is greatest. So being great friction, it offers also great resistance. And in the second point, we are going to talk of law of friction and the use of friction, as I described in this umbrella of closets, and then the video of motion. How do people move? If there was some sliding, then there wouldn't be any movement. The step you make will be just sliding back. So before you slide back, you first have to analyze that there is friction that holds you there, and you make another step. So I'm going to use this video and this umbrella of charts and closets to give us a clear picture of what frictional law states and how do we use friction. Yeah, so in the next explanation, we shall have the third topic, the third subtopic, and this third subtopic is momentum and impulse. So for momentum, we just have to know that a moving object just have mass and its velocity. A moving object has mass and its velocity. So having mass and its velocity, we time this, and when we time this, when we time it, we time from a given point to the next point. Then you see that if you time, you can see that when we time, we can see that when we time, and the timing will give us, actually, the timing will give us the very quantity. Yes, if we could see the moving object over here being pulled by the red force, 100 kg being pulled upward from a given point through a 10 meters distance, and then when our time here begins to count, for the next study of impulse, so that means the movement, the product of those movement, that is the momentum, we study the time it takes, so that it gives us exactly the amount of time this block took to reach this particular time. Yes, the amount of time this block took to reach this particular time. And therefore, that study of momentum per unit time taken over this distance of 10 meters gives us what we call impulse. So we shall use that to explain what momentum and impulse is. And the next part of our third subtopic will come as the collision. You know, when we talk of collision, bodies knocking together, coming head on head, or just back on back, just getting into contact. Yes, getting into contact. Just as we can witness this moving car. As the reversing car comes and bangs on the parked car, the parked red car. So now the first type of collision I want to talk of will be explained by their movement after collision. How do they behave after collision? Do they move together, or they move? Do they move together, or they move? Do they move together, or they move differently? Do they move together, or they move differently? Yes, if they move together, then that is different. That is elastic. I mean, that is inelastic collision. Yes, that is inelastic collision. And now, when they just bang and they separate and they don't move together, then that is what we call elastic collision. So we shall be explaining what elastic collision and what inelastic collision is in the next presentation. And in our collision, in our fourth subtopic now comes work, power, and energy. Here we come with work, power, and energy. So our work, power, and energy will be explained in the normal way. How do you define work? That is doing something, just like my mama here. Mommy is doing work in the garden, lifting the hoe up and down, and in the last point, you find her digging some part of the ground. So that means in critical analysis, there is lifting of the hoe from one point on of the ground upward, then bringing it back. So that is already the doing of the work. Yes, that is to say, when force is applied to a pattern, to a particular object, then it moves through a given distance, say D. So for the garden, for the mama in the garden, she lifts the hoe from the ground up to a certain limit and then brings it back. So that movement is work done. So you do work by lifting, by moving a force, by force moving the object. So that's that case. And then also through the components, we can see that the components of work is explained by this videos and the closets showing you how useful, how useless, or how effective is the work done. It is only useful when you can overcome the friction, but it is useless when you cannot overcome the friction. Just like the second boy here. The second boy here cannot overcome the friction. So it is useless work already done. No distance moved. Yes, if no distance moved, force applied may be counterreacting the frictional force, and there's nothing to do as work. So that is useless work done. You push and nothing is experienced. But when there is useful work done, you can move object from one point to another. Next here is my picture for effective work done. That is when the force applied less the force, for the frictional force and times the distance, then gives us the effective work done. So that is when there is a frictional force, and then there is a pushing force, and you subtract the pushing force minus the frictional force. That is when we shall get the effective work done. So then that gives us the explanation of work as part of force or an effect from force. Yet still we are talking of power. What could this power be? Just as a rate of change, a rate of doing work, we can see that power can light. There is movement, there is motion of this horse and the like. So this picture here over here explains what power is. Then you can also imagine climbing a cliff, climbing stairs. Yes, that is power, the rate of doing that work. The work is lifting your leg upstairs. Now, how long do you take? That one becomes the what? The power. So this picture explains it is a closet. Yeah, we have a closet here explaining what power is and how we can calculate it. Now, for the energy as applied in physics, we have a word web for the forms of energy. I will be using this to explain for us forms of energy, as in my fourth subtopic. I appreciate your attendance for today's exhibition. I also pray that you attend, you take time and attend what we shall be showing out as our presentation in-depth explanation, because this is just an exhibition of what we shall be using, what the visual aids will be guiding us. Thanks and be blessed as you come for the next presentation.